In this video, we're looking at our final construction of the Ordinary Level Junior Cycle curriculum, Construction 15, how to construct a rectangle when you've been given the side lengths measurements. This may seem like a very simple construction. However, as we know, constructions have to be very accurate, drawn with a sharp pencil, and we are required to use our maths tools. For this construction, you will need not only your pencil and your ruler, but also your protractor or your set square. It's really important that you include your construction lines, so we're not drawing a rectangle like you have done ordinarily in previous maths lessons. We need to follow the set steps as follows. So we've been asked to construct a rectangle where we have one side length, the measure of the distance between the point A and B, to be 9 centimetres, and a second different side length where we're told that the distance from B to C is 4 centimetres. Now, as you know, rectangles have opposite sides that are equal in measurement. So that means that whilst we only have 2 side lengths given to us, we have all 4 sides, as there will be a side opposite to this one that's also 9 centimetres, and then the fourth side will be opposite to this one that's also 4 centimetres. So we're going to start off as usual by drawing a sketch, and we have 4 vertices, A, B, C, D, the 4 corners of our rectangle, and it could look one of 2 ways. We know that AB as 9 centimetres is the largest side, and that the side opposite that must be the same. And we know that B to C, like this, is the smaller side. So it would look something like this, or it could also look like this, and either one would be correct. So we have our rough sketch. Again, I'd like you to use a ruler so that yours will look much tidier than this, but it's not going to be the correct measurements, and there's no need for any construction lines for a sketch, but it does help you to just identify where you're going to put each of the different points and which one of the 2 diagrams above here yours is going to end up looking like. Okay, so we start off by drawing a line. And we can draw that line quite nice and big. It has to be bigger than the line segment at the bottom. So we know that our line segment at the bottom from A to B is 9 centimetres. So we want to make sure that this is larger. The examiner is going to be looking that you have an extra pieces at the ends of this line. And once you've drawn this line, we're then going to use our ruler to measure the line segment. So ending at A and B, you can remember that the square brackets means an end point. And we're going to place them onto this line so that the distance between the 2 of them is 9 centimetres. So you can start off by placing a point for A and then putting your ruler up to that, making sure it's level with 0, finding where 9 centimetres, the required measurement, is, putting another dot on the line, and that's where our B is. And again, as always, we have to write any measurements that we've been given in the question onto our diagram. So we're going to write 9 centimetres. So as I said before, it's really important we don't rub any construction lines out, and the examiner is looking to have these extra 2 bits here that have gone beyond our point A and B. So next, it's time to start drawing the vertical side lengths. So we can start either at A or at B, it doesn't make any difference. And we're going to create the 90-degree angle. As we know, all 4 angles in a rectangle are right angles, they're 90 degrees. So we can use our set square or the protractor to create these 90-degree, these perpendicular sides. So in this example, we're going to use the protractor. So we'll line up our centre mark of the protractor with point A first of all, and we can see that 90 degrees is exactly above it, making sure that your baselines are in line. So the baseline on the protractor is exactly on top of the line that we created in our construction. We can then place a little marker with our pencil very accurately and neatly above where it is 90 degrees. And we can take our protractor away, and we're then going to connect our point A up through this point that we've just placed outside the protractor, and we're going to keep drawing up again. Nice and still accurate. And again, this is really important, that the construction mark isn't rubbed out, that we don't stop at this point. We draw it nice and high. The examiner's looking for these extra bits. And we know that that's 90 degrees. So you can draw your box or your perpendicular symbolic notation. They have written 90 degrees there, but I think the use of symbols is better. Now, we need this to be 4 centimetres. So this is where we will get our ruler back out, and we can then measure up to the number 4 and place our dot exactly beside it. Now, of course, you could use your compass to do that if you prefer, and that would be opening your needle and point and your pencil point and having a distance between them of 4 centimetres. Placing the needle then on A and sweeping around, and you'll have little curved lines then at the top, and where that curved arc from the compass intersects will be your point. So whether you've used the ruler or the compass, you will end up with your point above A, which from our sketch we decided was point D. And that's because we know that we have a measurement of the line BC. So B to C, so C has to be above B. That's 4 centimetres. Now we're going to do the exact same thing, but on the other side above B. So again, we're going to use the protractor, place the centre mark on B this time, where 90 degrees is, place our little dot above, and we're going to extend very accurately, being careful not to slip with your tools, right the way through that point. And of course, we need to mark on that it is 4 centimetres. That was given in the question. So in the question, we were only given AB and BC. So we will need to have those two measurements on our diagram. It's not essential that you have it written on the opposite sides. And the last thing to do then will be to connect D and C together. So there we have it. You've got all 4 sides of our rectangle, but the examiner is specifically looking for these extended lines to prove that you have constructed it in this way. Okay, so let's see it being done by hand. So we've been asked to construct a rectangle A, B, C, D. So that means the 4 corners, the vertices, are the points A, B, C, and D. And we've been told 2 of the side lengths, which are different in measurement. So that helps us to know that we know all 4. Like all constructions, we start off with a sketch, and I have started by just drawing a rectangle without any construction lines. We know that this is just a rough guide, but once I've done that, then I can start to figure out where do the different vertices go. Now this is the larger of the 2 sides that we've been given, so that means that my larger sides, the top and the bottom, I can pick any one of those. So I'm going to pick then A and B to go here, and they will have to measure 9 centimetres. And then I can look at my second side I've been given, which is from B to C. So that helps us know that this must be C, and that's 4 centimetres. So if we've already got A, B, and C on our diagram, then process of elimination, then point D must be above A. So this has really helped us to understand what our construction will end up looking like. So we'll get started. And again, we're going to start low down on our page with the bottom of our rectangle, so the line segment AB. So I need to start low enough that I'm going to have enough space then to complete the rest of the rectangle. So I start off by drawing a long line, a line that is longer than the required line segment. So as this was 9 centimeters, I used my 15 centimeter ruler and I drew a good section of a line about 14 centimeters long. So I know it's definitely then going to stick out on both ends. So now onto this, I am going to, at some place, I need 9 centimeters, so I can use my ruler to check that it's going to fit on, and I'm going to have bits sticking out on both sides. And I'm going to simply pick one location and decide that that is where my A is going to start. So I'm going to pick here for my A, and making sure my ruler is exactly at 0 for that, level with that dot. And I'm going to find 9 and then mark off my point for B. So again, you won't be holding a camera, so you can make sure that your ruler doesn't slip. And there we are. Once we have the locations of our two vertices, our endpoints A and B, we can use our pen then to label them. And we must make sure that we write on the measurement that's been given to. So far we have the bottom of our rectangle. So now it's time to draw our vertical sides, the side from A to D and the side from B to C. Now in the previous demonstration it used the protractor, so I'm going to use the set square this time. So I'm going to make sure that the right angled part of my set square, so it has to be the 90 degrees. And remember that you could simply check that it fits perfectly with the corner of a page or a book, and that helps you know that that's definitely the right angle if you can't spot it just from sight. So I'm going to line up the bottom one of those two perpendicular sides exactly onto my line segment AB. And then I'm going to draw the pencil line, making sure that the pencil point is exactly on A, not slightly to the right because my set square was too far to the right, and not slightly to the left because I've put my set square exactly on the point A. We need to make sure that the pencil, when you hold your protractor down and it's still, the bottom of the protractor is definitely still on this line, that your pencil mark will go through A, and we're going to keep drawing up definitely beyond the side length, which we know will be 4 centimeters, and we're going to keep going up above it. We need to show that we have got construction marks, that we have done it the correct way. Okay, so as you can see, the bottom of my set square is perfectly on top of my line, and the pencil line also is perfectly going from A, and then I continue to draw it right the way up to the top of my set square. And we, as always, need to mark on anything that's important, and in this case I'm going to mark the fact that it is a right angle, and I'm using this box symbol notation. Okay, so at this point now I need to decide where am I going to locate my point D. D needs to be 4 centimeters away from A, so I'm going to use my ruler again this time. So as I said previously, you could use your compass, and that again would be definitely an indicator that you have constructed properly because you've got arcs from your compass, but it's also acceptable to use your ruler. Making sure then that the 0 is exactly level with my point A, my bottom line segment AB. And where I find 4, without moving my ruler, making sure it doesn't slip, I'm going to then place a pencil dot beside that so that I have the exact location 4 centimeters away from A. Again, making sure that it lies on this vertical line that we've just created. Okay, so as you can see, my dot is exactly level with the number 4 centimeters. And we then label our vertex D. So we're going to do the exact same process now from B to create the line segment up for BC, but first of all creating the ray using the set square. So again, making sure that you're using the two perpendicular sides, the sides that are at right angles to each other, lining up the bottom of your line segment and making sure that your pencil will go through B and that you're not slipping and draw as high up the page as you can, making it still look nice and neat. There we go. If you find it difficult to make sure that your pencil starts exactly at B when you use the set square, then simply use the protractor or the compass instead. And just like we did to find point D, to get our point C, we are going to line up our ruler, making sure that the 0 is level exactly with B, and then we're going to locate 4 centimeters on our ruler and draw a small dot then beside it, which will be the location of C. Okay, there we have C, and we must make sure, as this was the piece of information given in the question, that we write on that measurement. And there's only one last thing to do, and that's to connect D and C. But again, this can't be just done very quickly. It must be accurate. Your pencil has to connect exactly. If you have it slightly underneath or slightly above, then it's going to be inaccurate. So really be careful to line up the pencil and your straight edge, your ruler, so that it's nice and accurate going through the points. And there we go. Some questions are, is it okay to extend to go completely through? Absolutely. You could continue through D and C. And again, that's just like we've got here, showing that we've constructed it, but it's not compulsory. So again, it's really important we never rub out any construction lines whilst we really are interested in this perimeter, in these 4 lines, that we still have these extras to show that we have performed the correct construction. So we'll have it demonstrated one last time. Again, each time that you see it, especially if it's done in a different format, it's an extra chance to understand. So you always start off with drawing a larger line. Now you could actually have this line at the top. So instead of being the bottom here, you could have it as your top line, and A to B be at the top and DC at the bottom. That's absolutely fine too. So once you've marked on the distance between your 2 endpoints at the bottom on that line, you're then creating your vertical lines. And this is demonstrating the use of the compass for the sides. If we want them to be 4 centimeters, then you will open your compass width to also measure 4 centimeters. And that means that when you place the point on B, you will curve your arc of your compass, and wherever it intersects your perpendicular line, that's exactly 4 centimeters above. And we can then connect the 2 together. So 3 different ways of producing this: using your set square, using your protractor, or using your compass. So on the screen right now is the notes that I would like you to draw into your notes copy, including the written steps. Please be sure to have a title, Construction 15, Rectangle. And one last thing before you go, just for fun, which monster is excellent at maths? Why, Count Dracula, of course. Thanks for listening, well done, and I'll see you in the next class.